4.2, we're going to look at some strategies for solving identity questions. First thing it says here is we're going to begin with a more complicated side. If one side contains operations, we're going to perform those operations and then simplify. So what you want to have handy is this summary of your basic identities, because you're always going to be looking for identities and ways you can simplify things. Okay? So let's get started. So what I did first here is I squared 1 minus sine squared theta. Squaring a binomial always gives me a trinomial. So I get 1 minus 2 sine theta, sine squared plus cos squared. Looking at my identity sheet, I know that sine squared plus cos squared is just another way of writing 1. So I have 1 minus 2 sine theta plus 1. So I have 1 plus 1. I have 2 minus 2 sine theta. Factoring out my common factor, I have 2 times 1 minus sine theta, and that was what I was trying to do. So I massaged my left side, I simplified, and I did what I wanted to do. Okay. Another strategy is if one side has more than one trig function and the other only has one, make both sides only have one. So you can see here my left side only has secants, but my right side has secants and tans. So what I did is I looked at my formula sheet and I said, well, what can tan squared simplify to? And more specifically, what can it simplify to in terms of secant? And I saw from my sheet that tan squared is the same as secant squared minus 1. Now what I'm going to do is I am going to distribute. So I'm going to distribute like this. I get secant to the 4th theta minus secant squared plus secant squared theta. Well, I have minus secant plus secant, that's just 0. So I get secant to the 4th theta, which is what I wanted to do. Okay. The next one says that you can break up the side with only one term in the denominator into many fractions and then simplify. So I have cotangent cubed plus cotangent plus cos all over cotangent, and I broke those all up into 3 separate fractions with the same denominator. I'm going to simplify. Cotangent cubed over cotangent is just cotangent squared. Cotangent over cotangent is just 1. And then I have cos over cotangent. Well, cotangent is just the same as, let's see if I can find it. Cotangent, where are you? Cotangent is equal to cos over sine right here, cos over sine. And so I'm going to simplify that as cos over sine. I have cos over cos over sine. Well, the coses cancel out. I have 1 over sine, which is the same as just sine. Okay, so now I'm getting close to where I'm going here. I have cotangent squared plus 1 plus sine. Well, looking at my identities, cotangent squared plus 1 is the same as cosecant squared theta plus sine. So always flipping back to that formula sheet, getting to know those first 8 identities. Next strategy, I'm going to look for opportunities to factor. And I know you guys love factoring. I taught you this in grade 11. I know none of you have forgotten how to do this. Oh, this is just a sum of cubes. To factor a sum of cubes, all we do is we take the cube root of the first term, the cube root of the second term, and I multiply that by the square of the first term minus the product of the 2 terms. And I know you guys can do this in your sleep, right? Plus the square of the last term. So it might be a good idea to look up factoring cubes, a sum of cubes, and a difference of cubes, in case you guys forgot how fabulously I taught that to you. Okay, so I factored the numerator and the denominator just stays the same. And now that I've factored, I notice that these two can cancel out, and I'm just left with cosecant squared theta minus cosecant theta sine theta plus sine squared theta. Okay, well, cosecant times sine, this right here is just 1. So I have cosecant squared theta minus 1 plus sine squared theta. And the other thing that I notice is cosecant squared minus 1 is just the same as cotangent squared from my formula sheet. And I did what I wanted to do. So I'll just show you where that cotangent squared minus 1, or cosecant squared minus 1. Cosecant squared minus 1 was right here. Okay, if I brought the 1 over, I'd be left with cotangent squared. So just getting to know my identities. Okay, now I'm ready for the fun ones. This one I'm going to multiply the numerator and the denominator by the same factor. Okay, so this is something that might get you where you need to go. So I'm going to start with the left-hand side, and I multiplied by sine over sine. What that gives me is sine theta, minus cos times sine, all over sine squared theta. And you're saying, well, why did I do that? What that gave me is sine squared theta is the same as 1 minus cos squared theta rather. And actually, I shouldn't have expanded that. I should have left this guy the way it was, sine times 1 minus cos, just because I know where this is going. Well, 1 minus cos theta is a difference of squares. This is 1 minus cos theta and 1 plus cos theta. I think I showed that 2 videos ago. Okay, and we have sine theta 1 minus cos theta. And now you can see that these are going to cancel out. I have a common factor. So I am left with sine theta over 1 plus cos theta, which, lo and behold, was what I was trying to do. Okay, it's critical that you are willing just to try substituting different identities in. Sometimes you find an easier way to prove the same thing. Sometimes you take the long route. Either way, it's the journey that will teach you how to be confident in proofs. There's a life lesson, the journey. Okay, if all else fails, we change everything into sines and cosines. If you look at something and you say, I don't know how to do that, sine and cosine it. Okay, and then we're going to see if we can make this into tan squared. So I said cosecant is the same as 1 minus sine, and cotangent squared is cos squared over sine squared. So now I just need to play around with these fractions. I need to try and combine them into tan squared. Okay, so this is the same as sine theta over 1 over sine theta, and I'm going to combine this, minus sine theta over sine theta. That's the same as 1. Okay, this one I have a number divided by a fraction, so I'm going to kiss and flip. So I'm going to multiply by its reciprocal, so I get sine cubed over sine squared theta. Oh, cos squared theta, rather. Okay, on this side I have sine theta over 1 minus sine theta over sine theta. Kissing and flipping that, and this stays the same. I don't need to simplify that anymore. This becomes, kissing and flipping becomes sine squared theta over 1 minus sine theta. Okay, and I have the same thing over here that I'm just carrying that down. I haven't changed that. Okay, what I want to do is I want to get a common denominator between these two terms so that I can combine them. And so I need to get cos squared theta, and I don't know that cos squared theta is the same as 1 minus sine squared theta. So that's where I'm going here. I'm going to make this into 1 minus sine squared theta, so I'm going to multiply it by 1 plus sine theta. And what that's going to do is that's going to give me 1 minus sine theta squared. Okay, which is the same as cos squared. So here I have, this is going to give me sine squared theta plus sine cubed theta over 1 minus sine squared theta, because this is, those are conjugates, is that the word? Yeah, that's going to give me 1 minus sine squared theta. sine cubed theta over cos squared theta. And I know this is a tough example, but doing a tough example shows where we're going. Just ignore this. Okay? So I have, this is the same as cos squared theta. So now I can combine my numerators. Well, if I look at my numerators, I have sine cubed theta minus sine cubed theta. That's 0. And I'm left just with sine squared theta over cos squared theta, which is the same as sine over cos all squared, and sine over cos is just tan. So I have tan squared theta, which is what I was trying to do. Okay, so all else fails, change it into sines and coses, try and use some identities to get where you need to go. Okay, identities are one of those things where you can't just say, oh, I know how to use them. You have to practice. You have to try examples. You have to look in the answer book. You have to ask your friends. You have to say, Miss Canelon, I just don't know where to go from here. The more examples you do, the more confident you're going to be for the pre-test, for the test, and the departmental, okay? Practice makes perfect for these.